Hello everybody. Okay, we have a new project. This is actually a virtual 555 timer type. We can call it a digital oscillator simulator. Okay, so what we got here, I put all together, there is a buzzer. Okay, we have here a buzzer. We have two buttons and a pulsating LED. Okay, so when you press this button here, the frequency increase. Okay, and when you press this opposite button, the frequency decrease. And you can see that the flash change as well become, and you can see also the motherboard of the ESP32C3. You can see the LED on board is also changing. Okay, so and that's the way. Now we have 500 megahertz. Then we go 100 megahertz. You can see it's flashing less than when it's 1000 megahertz. So now let's bring it back to 1000 megahertz. Just wanna see. Alright, and the buzzer is producing a turn from the square wave. Okay, so let me see if I can put my microphone on and you can hear it. And now it's 170, 180. Okay, the square wave are very to 600. Is almost down to 100. The buzzer is almost very soft. You can't hear it much. Okay, so that's the way it works. Bring the square wave back to the higher frequency. Okay, so practically we have the button on GPIO 10. Okay, this one here, and that increases the frequency. And then we have the button, this one here, which is on GPIO 8. This one will decrease the frequency. Then we have the I think obviously display on OLED. We have the pin number 5 here, which goes to the LED, which is grounded with a 220 ohm resistor. This is the ground railing, and this is a VCC railing. So the LED output blink or pulse depending on the button state. Okay, like for example, if you keep it pressed, it pulses, but at the same time, when you release it, it pulsates faster, if there is more frequency, and less if there is less frequency. Alright, then pin 4, the output of pin 4 here, this one here, goes to the buzzer. Okay, this sound output where the turn is, okay, that's where the turn generates the square wave. So the turn generates a square wave, and you can hear it when you press a button, the way it goes. And all this principle works similar to a virtual, well, it is actually a virtual 555 timer. Okay, now I think we will take a look at the code just now. Alright, so okay, so on the code side, we don't need a library. This project does not require any special library. It has the Adafruit GFX, which is for the OLED display the graphic, and the Adafruit SSD1306, which, if you look at down here, wire begin, it's initialize the OLED screen display, which is, in my case, it's on pin number 7, not pin actually, GPIO number 7, and GPIO 6, where the GPIO 7 is a SDA, and the GPIO 6 is the SCL. My ESP32C3 require to be told which pin it's SDA and which pin is SCL, because if you don't, your screen, if you don't put the pin number correctly, your screen will stay blank, will show nothing. Okay, so that's the one. Then obviously we have the turn function, you know, which with the pin with the frequency generates a square wave for the buzzer to produce a sound out, as you heard earlier on. What I'll do, I'll try again with the microphone much closer, because it doesn't come up very high. Okay, so obviously your button press, here we are, you have a button up, number 10, GPIO 10, and button down is GPIO 8. Then you have, because obviously 1 decrease, the 8 decrease the frequency and 10 increase the frequency. You have the LED pin on GPIO 5, which blink or pulse depending on the button state, as I said earlier on. And then you have the output 4, which is it's a sound output where the turn generates the square waves. Okay, so that can be, you can actually plug it into a 555Timer or any other logical gate. And also you can plug it in a speaker, or you can plug it in my case, with a buzzer. Okay, so that will be the output pin 4. Okay. All right, so we have also the frequency start at 800, and the step, when you press a button, it steps up 100, 200, 300, or it steps down minus 100, 100, 100, and so on. Okay, so this is initializing the button. You don't need to put any resistor. If you have the input, the pull up, and an input pull down, pull up and pull down. Okay, so that's it. I think we explained everything. And mainly down here we have the display. The square waves. Okay, this is the trigonometry for display the waves. All right. So practically, these are the code. I don't think we got much to talk about along here. Yeah, I think we explained everything. And this is to initialize your, what do you call it, your OLED display. In my case, it's a small one. It's 128 by 64. It's the width is 128 and the height is 64. Okay. So I think I covered almost everything, and here, down here, it's obvious it will show also the frequency text on the frequency. Okay. All right. I just want to see if I can produce the sound again. I'm going to put the microphone closer. Okay. Hold on. Alright, I hope that this one is recorded well, but I will double check. So practically we covered everything. Remember the pulsating LED, the turn of the square wave, and some, you might ask as well, how does it relate to a 555 timer? But remember that the capacitor and the resistors are the one that control the square wave, the frequency. So practically, if you replace the button with the resistors, as you increase the resistor or decrease it, the square wave will change the value, obviously. And usually there is, you have a voltage divider, usually on the and it's what I would call it is, it's a stable mode. We have you have a resistor with 1K and another resistor perhaps with a 10K, and you change them, and that will change the frequency based also with a microfarad of 10 microfarad or 100 microfarad of the capacitors. So it's pretty similar. I'll try to do one with an actual timer, something like this. Maybe it'll see if I can bring the fluctuation of the this is a timer, but I've blown it. It doesn't work anymore, so I'll just order another 10. Actually about 20 of these, so see if I can burn them more. They tend to be very susceptible to electricity, current. Okay, so I think I'll try to do one connected to a project connect. Instead of using button, I use resistors. Instead of using the buzzer, I'm going to use a 555 timer. Or even a Schmidt trigger would probably do a good job as well. And the display, to display the frequency and with the pulsating LED. Okay guys, I hope you like it, and thank you very much. Have a good day. Please give me a thumbs up if you like it.